everyone. Happy Monday, Algebra. We are kicking off the week with PO7 Part 1. That's how you know it's going to be a good one. There's always a Part 1. You know there's a Part 2, so it's going to be glorious. Solving multi-step equations. And like we briefly talked about before we started recording, objectives 21 and 22 on your entrance exam was essentially this. So many of you have already shown me you know how to do this. It's just going to be kind of the algebra version, so a little bit deeper, a little bit longer equations, a little bit more stuff to do. If you have not passed it, then this is going to be a great opportunity to kind of get the lesson so you can then plow through 21 and 22 from your entrance exam. But multi-step equations. We've talked about two-step equations before. That was more in PO6, you know, and they're called two-step equations because it takes 2 steps to solve them, right? You've got a constant and you've got a coefficient. You add or subtract, then you multiply or divide, right? These are called multi-step because they just take more than 2 steps, okay? And through the methods we're going to talk about today, combining like terms, distributive property, and variables on both sides, you'll find that, you know, once we get to that 2-step equation, then we're in business, right? So kind of the goal of this is to break it down to a 2-step equation, and then you go. Okay, so tell me about combining like terms. First of all, what are like terms? Like terms, Jack?
Like terms, putting on the first one, like putting 9x and 4x together, then putting 3 and 43 together.
Okay, so examples of like terms would be terms with the same variable. Okay, terms with the same variable. Jack brought up, said, you know, for example, this 9x. And what would the like term be with the 9x? In that negative 4x. You do need to remember that subtraction sign is really a negative belonging to the term that comes after it. So terms with the same variable would be like terms. What else would be considered like terms? If you look in the second example there, you see you have an 8n and a negative 11n. The third example, you got some more stuff. So what else could we combine, Kylie? Constants, right? Okay, so terms with the same variable or constants are considered like terms. And there are others that we call like terms, but for our purposes here, we're going to focus on that. Terms with the same variable or constants. I should put a comma because terms can't have the same constant. I suppose I could, but terms with the same variable, comma, or constants. Separate those. So 9x minus 4x plus 3 equals 43. We've identified 9x and negative 4x. How would we combine those? Alex? So how many x's do we have? 5, right? Why wouldn't we add 4x to 9x? Because usually when we're working with equations, we're always thinking opposite operations or railroad tracks or whatever, right? But why do we subtract there instead of add? Catherine? Sorry? It's a negative 4x, right? It's be 9 minus 4x. But if you think back to like PO6, you know, if I had to always did the opposite operation of what was there. If it's a negative 4x in the equation, why don't we add 4x, which is the opposite of that? Joey? Exactly. They're both on the same side. We aren't moving the term from one side of the equation to the other. It's staying on the same side. So we do not use opposite operations there. And what do we have now for your solving pleasure? A 2-step equation. Step 1, subtract 3. Step 2, divide by 5. Now we're going into opposite operations because now we've got to move one term from one side of the equation to the other. That's where opposite operations kicks in. Okay. How about the next one? 8n plus 2 minus 11n equals 29. What are the like terms here that we can combine? Catherine? 8n and negative 11n, right? So how many n's do we have in all on that left side of that equation? Kylie? Negative 3, right? 8 minus 11. You know, whatever n is, we've got 8 of them, right? Because that coefficient tells us how many we have. We start with 8. We subtract 11. That leaves us with negative 3. And now we have our two-step equation to solve. Subtract 2, divide by -3. Okay? Third one there, 7 minus 10n plus 3 minus 2n equals -122. What are the like terms that we have? Jack, give me one set. 7 and 3. Give me another set. Ellen? -10n and -2n, right? We've got terms for the same variable, those n terms, so they can be combined. And then we have constants. Don't have a variable, they can be combined as well. So what would our equation be that we'd actually be solving here? After you combine, yeah.
10 minus 12.
Excellent. Yep. So it wouldn't be minus -12, because if we were to write 10 minus -12n, what do we know happens when we subtract a negative, Alex? It actually is the same as saying 10 plus 12n. So yes, it's a -10 minus 2n. That just gives us -12n, right? So that sign kind of has a dual purpose there. It's a -12n, and it also tells us we would read this as 10 minus 12n. But you would not write 10 minus negative, because that would actually turn into a positive 12n, which is not what we want. So good. 10 minus 12n equals -122. If you wanted to write this as -12n plus 10 equals -122, why is that okay? To put that n term first here, the way that we've written it. Kate? Claire. Why? Oh my, you know what? I've called students by siblings' names. I've never called a student by their mom's name before. That's a new one. Claire.
Because as long as you have the negative, it doesn't matter.
As long as the signs are the same, right? -12n, -12n, +10, +10, it doesn't make a difference. Okay? So, obviously, these aren't solved yet, so you still have some work to do here, but we've got it down in that two-step equation. Any questions on combining like terms? No? Okay. On to distributive property. Okay. Tell me about the distributive property. How do you know when you're going to have the opportunity to use it? Max.
When you're like, you have two numbers in a parentheses and you're timesing a number by
Right.
equals.
When you've got parentheses with a coefficient on the outside, that's going to be your clue that we're working with the distributive property. Because what does the word distribute mean? Thank you. Yes, the word distribute does mean distribute. Crinkle, expand on that.
Like to send to give like to another, or like
Right.
each people gets a equal amount of rice.
Sure. Yeah, great example. Okay. You know, when a teacher asks you to distribute worksheets to the class, it means to give one to everyone, right? So the distributive property, the goal is to undo parentheses, right? Like we talked about with the order of operations, parentheses they aren't an operation, so there's no opposite to parentheses. So to undo them or to get rid of them, we have the distributive property. And like Crinkle said, it means to give to all, right? So this 7 times 3n minus 5, to distribute this, we're going to multiply everything inside of the parentheses by 7. Because really what this is saying is that we've got 7 groups of 3n minus 5, which means we have 7 groups of 3n, which is a total of 21 n's. 7 groups of 3 is 21. And we have 7 groups of -5, which would be -35. 7 times -5. And that gives us to 21n minus 35 equals 7. It's a two-step equation, and we're off. Okay, you'd solve it from here, right? What would another option be? I usually don't show this. But what would another option be to solve an equation like this if you didn't want to distribute? Kylie? Why could we go ahead and divide both sides by 7 here if we wanted to? Max?
Because they both are, wait, never mind.
Alex?
Because 7 divided by 7 equals 1. And the unequal sign, after the equal sign, it's a 7.
So are you saying because these two numbers match? The 7 and 7? Or?
It can be divided.
Yeah. Basically, what this says on the left side here is we're taking 7 times something. We have 7 groups of something. If we were to divide both sides by 7, we're saying we have 7 groups of 3n minus 5. Divide that by 7. Well, just like, if it was like 7x or 7a or whatever, that 7 being a coefficient, they would cancel out. And we'd be left with 3n minus 5 equals 7 divided by 7 equals 1. And you'll find that if you solve either of these equations, you'll get n to equal 2. Either add 35 divided by 21, n gives us 2. Add 5 divided by 3, n equals 2. Either way works. Okay? One way distributes, just deals with the left side to get rid of those parentheses. The other way kind of taps into opposite operations, divided by the coefficient, which causes these parentheses to fall off. Because if you take away the coefficient, there's no need for them anymore. You can solve it that way as well. It's good to know both methods, but it's probably better, if you're only going to know one of them, it's probably better to know this one, because there will be times when you have to distribute. You can't divide first. I shouldn't say that. You can always divide first. You shouldn't divide first because it gets really messy. Like in the second one, right? We wouldn't start by dividing by -2 because we have that 7 out in front there. It's going to make things really, really messy. So in this case, that second one, we would definitely want to distribute first. And what would we be distributing into the parentheses? Catherine? -2. Excellent. Okay. Why can't we first subtract 7 and 2 to get 5? It's very tempting. I found myself doing it before, but you can't. Ellen, why? PERMDAS. It all goes back to PERMDAS, right? We have to multiply before we add or subtract. So we can't subtract and then distribute a 5. We have to distribute the -2. That sign belongs to the 2. So what happens to the 7 is just comes on down. We'll deal with it later. And then a -2 times n is a -2n. And a -2 times a -6 is a +12. And that equals 39. Long John Subert.
I have a question.
Yes.
How'd you get n equals 2 on that?
For which one? The top or the bottom? So I didn't show the work, but now that we're in a 2-step equation, we'd add 35 to both sides. So we would get 21n equals 42, and then divide by 21. Crinkle.
But you also combined 7 and 12.
Right, we're not done yet, because we had that 7 out in front we couldn't do anything with. Now that we've gotten rid of the parentheses, now we can. What can we do to simplify this further, Ellen?
You can make it -2n plus 7, plus 19.
Right, we can combine our +7 and our +12 since they're both constants. And so we've got -2n plus 19 equals 39. And there's your 2-step equation to solve. Okay. The last one there, 3t minus, and then in parentheses, 8 minus 2t equals 12. What are we going to be distributing in here? And before you answer, know that I'm not trying to trick you, but I'm trying to trick you.
What?
I know, right? It's not nice to do on a Monday, but I know. What are we distributing in here, Sophie? -1, not the 3t, because the 3t is not what's being multiplied by the parentheses. That negative sign is kind of like a -1. So the 3t, like that 7 before, drops down. We'll deal with it later. The negative sign is what gets distributed into our parentheses, which basically just changes the sign of whatever we have, right? +8 becomes a -8. A negative 2t becomes a positive 2t. And then it was 12. I got the 3t because it was out in front, so it just came on down. Yeah. And how can we simplify this further? Maybe a new voice, someone we have not yet heard from today. Anthony.
Combine the t's.
To get what?
5.
Yes. Positive 3t, positive 2t, 5t minus 8 equals 12. And there's our two-step equation to solve from there. Add 8, divide by 5. That's it. Okay? Now, with equations that are going to have this many steps, with this many signs, with combining like terms and distributive property, the probability of you making a mistake is going to go up, right? It just happens. You have more stuff to do, there's more opportunities. So what should you do to help eliminate that silly mistake that causes you a point off on a test? Maybe it's the difference between having to retake an objective and not having to retake it, right, Christopher? Check your answer. Check your answer. Okay. Solving this out, we get t to equal 4. Okay. Adding 8 to 12 gives us 20. Divide 20 by 5, we get a value of 4. You've all got very powerful calculators. You can just type this in exactly as you see it. Just replace that 3 or that t with a 4. 3 times 4 minus parentheses 8 minus 2 times 4. Type it in exactly as you see it. Just replace t with a 4, and you'll get 12. And then you know you're right. Give yourself a pat on the back. Move on with your day. Yes? Well, then fix it. You are able to use a calculator on the test. Okay. I think there were some parts where I said that you couldn't. So if that's the case, I don't remember off the top of my head, then you'll get like 2 sheets of paper. One will be a non-calculator section. Then you'll do that one. You'll turn it in. They'll give the second part. You can use it on that. Were there any objectives that were non-calculator? Oh, yeah, the simplifying square roots, right? The estimating roots, like that one. So, yeah, this will be a 2-part test. And that one part you will not be able to calculate on. The other part you will. And this will be one that you will. Okay. Questions on the distributive property? I'm trying to keep this as brief yet informative as possible. So if you've got questions, please stop me. But I'm going to let you take it away from two-step equations because I think you know how to do it. Okay. The last type of multi-step that we're going to talk about is variables on both sides. Okay. And it seems intimidating, but these are all just one step away from a two-step equation, right? Because look at the first one, 16x minus 5 equals 12x plus 23. What do you need to do to turn this into a two-step equation? William?
Combine 16x and 12x.
Yeah, basically, and I want to be careful using that word combine because we do not want to confuse this with combining like terms. Like you could not rewrite this as 28x minus 5 equals 23. Why is that wrong? Why could you not write this as 28x minus 5 equals 23? Ellen, your hand was first.
Because you can't combine two things that are on different sides.
Right. Notice that our two x terms are on opposite sides of the equal sign. Right? So it's different than combining like terms, because with combining like terms, they were on the same side. So we would just add them, right, and get 28x. But being on opposite sides of the equal sign, what do we need to use here to get them together as one term of x? If they're on opposite sides of the equation, we need to use, Kylie? Opposite operations, right? So we would need to subtract 12x from both sides here because we're actually moving that 12x term, moving those 12x's from the right side to the left side. And so it would actually be correct to be 4x minus 5 equals 23. And there's your two-step equation. Okay? You could also move your 16x's over to the right side if you wanted to. That's an option too. Okay, you would end up with the same result. It'd be a -5 equals -4x plus 23. But most folks, just for consistency, like to move over from the right to the left. Those of you that play sports, one way to think about this is that if you're in a basketball game, that's kind of a basketball score, 16-12, and your coach calls a timeout, it's late in the game, 45 seconds left or whatever. Coach might say, all right, the score is 16-12, right? Or the coach might just say, all right, we're up by 4. Right? It doesn't really matter what the score is. 16-12 is the same as 80-76. You're still up by 4, right? It's a 4-point difference. You just have to score more points than the other team. It's not the first one to get to a certain total. So if you think about this, one way to visualize this is thinking, all right, how many more X's do I have on the left side? I've got 16 on the left, 12 on the right. How many more are on the left? 4. Right? And if you think about it, 16 and 12 is the same as, in basketball terms, 4-0. You're up 16-12, you're up 4-0. What's the difference? So if you think about it like that and say, how many more X's do I have on the left side? 4. That's the same as having 4 and nothing. You can write it like that. If you like to think about it using opposite operations, the more mathematical sense, that works too. That works too. Okay? What about for the second one? Let's do opposite operations first. How would I combine? I shouldn't use that word. I just did my own thing I said I shouldn't do. How would I write this equation with only one n term? What would I, using opposite operations, what would I do here? Alex? We'll come back to that. Thank you, though. I don't want to forget that. Catherine. And how'd you get that -3n? Yeah. Since it's a -5n on the right and we want to move it to the left, the opposite of a -5n is a +5n. Right? So we're going to add 5n to both sides. On the right side, it cancels it out. -8n plus 5n is a -3n plus 9 equals -18. Don't forget, folks, that subtraction sign belongs to that 18. So it's going to equal a -18 on the right-hand side. Okay? In basketball, actually, this wouldn't make sense for basketball. You can't score negative points in basketball. But thinking about quantity here, -8 and -5, I've got less or fewer n's on the left side, right? -8 is less than -5. How much less is -8 than -5? Aiden? It's 3 less, right? So -8 and -5 is the same as -3 and 0. Because -8 is 3 less than -5, -3 is 3 less than 0. So you can think about it in that sense also. Yes, Claire.
Can we just add 8n to each side and
Yep.
then add 18?
Yep. If you are a positive thinking person and don't like negativity, another option for you, instead of moving your 5n's over to the left, you could move your 8n's over to the right. And you'd still use opposite operations here. You would add 8n to both sides, which on the left side would give you that +9. And -5 plus 8 is a +3n minus 18. The only difference between the two methods here is that on one side, your n's are negative, -3n. On the other side, the n's are positive, +3n. Okay, it depends on which side you move to. But yes, that's an option too for you positive thinkers. Okay? When we have variables on both sides, we kind of get introduced to something a little bit cool. Okay, does anybody know what this symbol means here? The mathematical sense? Or did I just make that up just now? It's possible.
No, zero.
Anti-zero, down with, no, it has nothing to do with that. That is the no solution symbol, okay? And this particular equation, 9y minus 12 equals 9y plus 18, actually has no solution. Wait, what? Math all of a sudden doesn't have an answer? I thought there was always an answer in math. How is there not an answer? My life is falling apart. Why is there no solution to this equation? Aiden. You can subtract 9y from 9y, but what you get is 0y, right? We've got the same number of y's on both sides of the equation here. And as Aiden said, when you move one of those terms to the other side, you subtract 9y, what happens? You get 0y. As it turns out, these end up canceling out. And the equation that we're left with is negative 12 equals 18. Is that true? No. There we have the no solution. Okay? Now, Claire.
Does that mean the next equation has no answer? No, that one.
Oh, I'm just going to, you just wait for it. Okay? But hold on. Let's come back to this one now. Folks, let's come back to this one. Who can logically explain to me? We mathematically explain why it's no solution because you subtract the 9y's and they cancel out. You have 0y. And this is what you're left with, which is not true. But logically, why would this have no solution? Kylie, your hands up first.
Logically, 12, if you have negative 12 or something, it can't equal 18.
True. I mean, those are constants. There's no variables left, right? This is the value of negative 12 equals the value of 18. No, they don't, right? No. Okay, Max?
So on both sides there's 9y and they're both the same exact number. How can you minus 12 from one of them and add 18 to the other and equal the same number?
Max, someday you'll be up here. Brilliant. Yeah. 9y is the same thing on both sides, right? Since our variable y has to equal the same value in the same equation, whatever 9y is, it's the same number. And if you subtract 12 on one side, but then add 18 on the other, on one side you're getting smaller, it's never going to be equal. It doesn't matter what y is. Thus, we have the no solution symbol. Are you ready for the next one? Does anybody know what this symbol means here? Yes.
You're not wearing a pin.
I'm not, sorry. I got too excited about this. I didn't even think.
Got a big tie.
I didn't even think. What does that symbol mean there? Arlene.
Well, it looks like you get the same answer on both sides.
Yeah. When we combine like terms on the left side there, what do we get? Bryn? We get 7, right? 2 and 5 are both constants, so we can combine them, and that gives us 8n plus 7 on the left side, and 8n plus 7 on the right side. N could be 1, or it could be 17, or it could be 5, or it could be 1 trillion, or it could be, right? Okay. 3, 2, 1. You are quiet. Why can n be any number here? Ellen. Because 8, just like in the last one, whatever n is, 8n is the same 8n as on the right side, right? So these two values are the same, and then we do the same thing. We add 7 on both sides. So we're always guaranteed to get the exact same value on both sides of the equation here, okay? Like our previous example, because these 8 n's are the same, they end up canceling out. And we get the equation 7 equals 7, which is true. Okay? And so this symbol here means all solutions. We have the no solution symbol, which is the 0 with the line through it. And we have the all solutions, which is like a double stemmed R. If you didn't see me write it, you kind of make an 11. And then you start at the first line and make an R with the second.
Oh, now I see it.
Yeah, it stands for all real. It's really all real solutions. You know, all solutions.
That is a minus equal to.
Okay. So Alex was very concerned about us not writing a goal for variables on both sides, and thank you for the reminder. The goal is to write the equation with one variable term, right? 16x minus 5 equals 12x plus 23. We want that as just 4x minus 5 equals 23. We don't want two x terms. We want one variable term. And to do that, we use opposite operations. Okay? You can't combine them like you did with combining like terms because they're on opposite sides of the equal sign. You must use opposite operations or think about it like the basketball thing or whatever you want to. Okay? Questions on this? I know it's been just word vomit by me spewing this out, but like I said, it's kind of review in the sense that you had it on the entrance exam, and it sounds like you've been introduced. I mean, it looks like we learned something new today with these two symbols here, so that's good news. But questions on this? Okay, your opportunity for the number game, which is what I'm going to call homework from now on, because it sounds so much more positive here. Your opportunity for the number game. Using the combining like terms method, write an equation with a variable value of 5. What I mean by that, which means you can't use the example I'm going to put up on the board, but combining like terms means that I've got two variable terms, right? So I might write 3, I already messed it up here, 3n plus 7n minus 6 equals 44. If you solve that equation, some of you are doing it mentally ahead right now. If you solve that equation, what do you get for n? 5, right? Add 6 to get 50. Divide 50 by 10 when you combine like terms. That's what I mean by a variable value of 5. So that when you solve the equation, n will equal 5. Okay? Well, 8 minus 3 is not a combining like terms method, right? So it's got to have a variable. Also doesn't have a variable, right? What's that? Well, 8n minus 3n equals what? Equals 5n? What does n equal here? If you solve this, n equals 1. It's also an all reals equation, so it can really equal anything. So right, you're writing an equation. Don't try and cut corners here. Just do the thing. It's almost easier not to try and cut corners because then you run into things like this where n doesn't, I mean, it could equal 5, but it could also equal anything else.
Did it equal anything in our answer?
It needs to equal 5.
What is the equal 5?
A variable value of 5.
Yeah, but like can the answer be whatever we type?
Oh, like here I have a 44, you mean?
Put random numbers.
Yeah, well, yes. Yeah, but the variable has to equal 5. So when I solve this, it equals 5. Okay? Then the next one, using the distributive property, write an equation with a variable value of -7. So again, you're writing an equation. It's got to have parentheses, right? You've got to be able to distribute. And when I solve the equation, I get an answer of n equals -7. The variable has to equal -7. When I solve it, the variable equals -7. Okay? Then, folks, hold on. The last one, or the next one. Write 3 different equations that have variables on both sides. The first with a variable value of 9, so n equals 9 when I solve it. The second with no solution. And the third with infinite solutions, or all real solutions, or that symbol there. So 3 equations are needed for that one. One of them has 1 solution, with it being 9. The second, no solution. The third with all solutions. Yes, Alex?
The second one is n equals 5. I mean, no, wait. N equals 9. I don't know. Pencil?
The writing I did earlier is now lost.
Oh.
It's not still on there, if that's what you're looking for. Okay. Then finally, real world. The membership fee for joining a camping association is $45. A local campground charges members of the camping association $35 per night for a campsite, and non-members $40 per night for a campsite. So you pay $45 to be a member, and you get a cheaper campsite rental versus just showing up, and you have to pay a more expensive campsite rental. So if you're only going camping one time, would it behoove you to become a member? No, because you're paying a lot more. If you're going 50 times, should you become a member? Yeah. So the question here is, your family's planning to go camping 9 times during the summer. Will your total cost be cheaper if you become members, or will it be cheaper if you stay non-members? What's more cost effective for you? If you plan on going 9 times, should you pay the membership fee and thus get cheaper campsite rentals? Or is it better for you just to show up each 9 times, don't become all 9 times, don't become a member, and don't answer now. It's for you to do. Okay, what's going to be the cheaper option? Question, Rowan.
Would it be like 9 times in like 9 times in a row, or would it be
Just 9 times for the summer, right? The membership lasts for the entire summer. It doesn't matter, when you go, it's just the number of times you go. Okay? All right. This is probably going to be the longest video you have all year. You've done it. You've survived. Ellen?
On the last question, it says your family's planning going camping 9 times. Does that mean like 9 nights?
Yes. Like 9 campsite rentals. Yeah. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Thank you. All right, opportunity for the number game is here. It is due tomorrow. We'll continue with this and then get into CO28 probably over as well. Well, it's for homework, yes, but I don't want to be so negative because homework is such like a bad connotation. So yes, it's homework, but we're calling it an opportunity for the number game. Okay. That's all you math.